Okay, in this question, number 18, what we have here is a question where we're going to ask you to analyze a quadratic. And analyzing a quadratic is really done through use of the discriminant, and that's the b squared minus 4ac part of the quadratic formula. And again, remember that that discriminant is in the quadratic formula right here. It's the part that's underneath the radical. Okay, so that's what we're going to do, and that's going to tell us a lot of information about our quadratic. And this was in your note packet. We had two charts that gave you lots of information about the discriminant. That's what we're going to use here. So let's first evaluate the discriminant. So for the discriminant, we've got our a, our b, and our c, and our a here is 1. So b squared will be 10 squared minus 4 times a, which is 1, times c, which is 25. So in this case, we get 10 squared, which is 100, minus 4 times 1 is 4, times 25 is 100. And oh, look at that. That gives us a discriminant of 0. When you get a discriminant of 0, this is actually one of the happiest problems you could possibly want to do. And you'll see why here in a second. Well, as we learned on one of the previous questions, when a discriminant is 0, that gives you one solution, because if you have plus or minus 0 here, you get 0 as your answer, and that gives you the same solution either way. And because the square root of 0 is real, that is one real solution. Now, how many x-intercepts will your graph have? Well, if there's one real solution, you'll have one x-intercept, because the graph of that parabola would only touch the x-axis once. So we're going to have one x-intercept. Now, the question is, can that be factored? Well, a quadratic can be factored anytime you are not going to have a square root or an imaginary number in your final answer. And in this case, because you're taking the square root of 0, you will not have a square root, so therefore it can be factored. So the answer to this is yes. And how do we know? And that's because the discriminant is 0. Okay? So because the discriminant is 0. Now, would completing the square be a good option? Okay, well, in this case, our a is 1 and our b is even, and that's really the preferred values of a and b if you're going to complete the square. So the answer to this would be yes, because a is equal to 1 and b is even. So a is 1, b is even. Okay, so it looks like this can be factored, and completing the square works out quite well as well. So that gets us down to our final answer. What would be the best method to solve by? Well, if a quadratic factors, that's really going to be your best method. You may not think that factoring is, the best way to go. Some people like to use the quadratic formula. The problem with the quadratic formula is there's lots of chances to make lots of errors between the negative signs and all the arithmetic. So in the next unit, you'll be factoring a lot, so you'll get a lot of practice, and you'll find that factoring becomes quite easy the more you do it. So factoring should be your preferred method. Completing the square would be the next best method if factoring doesn't work, and completing the square is a good option. And then if neither of those are good options, then you would use the quadratic formula. But in this case, it does factor, and not only does it factor, you might recall me saying that because discriminant was 0, this is like the best problem you could possibly want. And that's because there's only one solution. So when you go to factor this, both factors have to be 100% the same. That means the first term in each has to be the same, and it has to get you 1x squared. Well, what times itself gets you 1x squared? That is x and x. And actually, let me rewrite this here. X squared plus 10x plus 25 equals 0. That way we don't have to keep moving up and down. Then the last term here times the last term here has to get you the last term there, which in this case has to be 5. And then both of these have to be positive because your middle term is positive. So this is lovely. There's only going to be one answer. We know x plus 5 has to equal 0, so x has to equal -5. Okay, so your best option was factoring. So make sure you specify what the best option was, which was factoring, and make sure you list your solution.